Greetings, the Astro 30 here yet again with a brand new video for you. Well, yesterday I was messing around with this simple home audio power amplifier, and I was doing the basic preliminary voltage tests of the DC offset on the output. I noticed it was around about 50 odd millivolt. So there was a suggestion in the comments, and if you haven't seen that video, I'll put a link in the description and a card up here. But there was a suggestion in the comments that I could adjust the 1K5 resistor, which is in the collector of the long tail pair of the first transistor, to reduce that DC offset by using a variable resistor of say 2K, and then set it for 0, and then I could probably measure across that variable resistor and figure out what the resistance should be. Well, I agree the resistance is probably too high, but at the time when I was testing this amplifier on the breadboard, it was at a slightly lower voltage of plus minus 20 volt. So the DC offset was around, I think, 8 or 9 millivolt. I'll have to go back through footage of the previous videos on this, I can't remember. What I want to do is confirm what that DC offset is with a different multimeter here. So I've got everything set up, power supply, power amp, the output is connected to the multimeter and ground here to measure the DC, and everything is connected. Positive is connected where it should be, negative is connected where it should be, transformer's connected. Highly unsafe, but we're going to plug it in and find out. So here we go, and I will preface this with, if you're doing something similar to the way I've got things set up here on the desk at home, you do so at your own risk. Please adhere to basic electrical safety. If you don't know what you're doing, don't do it. I do know what I'm doing, so I'll plug it in. And yeah, I can see there is a minus. Well, once it settles down, it's actually higher on this meter. As everything's settled down, it's starting to go up into the minus 128. Now it's coming down again, which should make up its mind. It seems to have settled down now around about the 60 millivolt mark, I'm going to say. Is that DC offset acceptable? Well, yes and no. It's not going to do any damage to your loudspeakers. But yeah, considering I had a lot lower DC offset on the test amplifier before I built the PCB, I don't really like that. I mean, even though the silk screen says 1K5 on it and it's already assembled and all that, I want to actually try and bring that DC offset down, and really practically speaking, that 1K5 resistor should be more about around the 560 ohm mark, not 1K5, so it needs to be at least 1K smaller. Having said that, it didn't work on the breadboard version when I lowered that resistance. The long tail pair quit to function. That could be either through poor wiring, of course, or just too low of a voltage. Now we're at the actual designated supply voltage of this amplifier. I really want to try and tune that. Adjusting the collector resistor is one way of doing it. A more tried and true method is to actually put a variable resistor in the emitters of the long tail pair via two 100 ohm series resistors, so you're not bringing the voltage too hard one way or the other, so there's some form of resistance there. And then connecting the center wiper of the resistor to the positive rail, or in this case through the 22K resistor to the positive rail, and then you just adjust the pot to zero out the DC offset. Another way is to match these input transistors HFE, and I don't have a tool to do that with currently because it's in storage, and yeah, that's another story. Even if your HFE of one transistor is say 119, that's its gain, and the other one says 121, well, they're not very closely matched. It's still 3 volt gain there, difference, which can actually mean a rather high DC offset. So matching your input transistors is one. Having a constant current source and a current mirror in the long tail pair would also go to greatly reduce your DC offset, plus also your distortion. That again is a whole other topic of another video. So what I'm going to do is I'm going to have to go out to JCar because I don't have a trim pot of that size, 2K. I'm going to need a 2K pot. I don't have a trim pot of that size. So I'll go out and buy one, and I'm going to remove the 1K5 resistor, which I can't for the life of me remember where it is. I think it's right next to the transistors here on this side on the right. Pop that out of circuit, pop the variable resistor in circuit, set the resistance of the pot to around about halfway, and then power it back up and play with the pot. It's better than playing with myself. Penis! And a short time later I'm back from JCar with some parts. I've got a single turn 2K pot here and a pair of 115mm sized side cutters, because the ones I'm using are okay for cutting wire but not so great for electronics like cutting leads or components. These are much more of a precision type of side cutters, but that's irrelevant for this video. So what I plan to do with that pot is, or trim pot, I plan to put it on the underside of the board across the wiper connector and one of the outer pins, probably this one. Set this pot to middle and just cut the original resistor out of circuit. So this will now be a surrogate resistor in its place, and I'll be putting it on the underside because it's, well, easier to get to on the underside. Okay, this is very dodgy, but it is across the original resistor. The resistor is cut out of circuit. It's set to roughly halfway, so we should have about 1K there. And I believe to decrease the resistance, I'm going to have to turn it clockwise. So first we'll plug it in and verify that it still is functioning. Actually, let's improve the DC offset where it is. At roughly 1K, we're now down to -12. Wow. Okay. So I'm going to carefully turn this pot clockwise. You can watch the meter. See how that jumped. Now it's going up. We need to go the other way. It's too far. This is going to be very fiddly because it's not a multi-turn pot. So I fear, oh, it's going back up to where it was. So what I need to do is I'll go to the millivolt scale, because that'd be a lot, probably much more responsive than what I'm doing now. And play with my pot. Getting there. -4. Now I've come back up. Oh, that's so fiddly. A multi-turn pot probably would have been better, but I couldn't justify it. Oh my god, look at that, 0 volt. Well, that's interesting. The question is, does the amplifier still work with that resistor value there? Alright, that's all set up. Now plug it in and see what happens. Oh, we still have an output, which is good. My 0 line on the oscilloscope's moved for some reason, but it's saying we've got 1.4 volt out. That's only because I'm on ×1 mode, so I'll just change that to ×10. Right, so we've got 14.5 volt out with the, well, the amplitude of the oscillator set to minimum. I'll just increase the amplitude. I'm going to have to change that. Okay, well, we haven't changed much in the way of how it outputs. Let's try that. Right, we're still pushing the 60 volt out, so we haven't changed the output much, although it has zeroed properly now. So I now need to know what the actual resistance of that variable pot is now. Just doing a quick heat test on the transistors. Nothing is getting hot, so yeah, the change in resistance is not affecting the circuit too much. Alright, I'm going to have to unsolder that variable pot now and measure its resistance out of circuit. Okay, according to this, it's more like closer to 820 ohm. I don't know if I have an 820 ohm. Right, I've been out to JCar yet again, and I've got the 820 ohm resistors that I need. I also went out and bought some beer to make it worthwhile my time going out again. It's a bit early in the day to be drinking, but I don't really care because I'm on holiday for the next couple of days anyway, so don't judge me. Cheers. And also, whilst I was out, a package came for me, and I think I know what this is. So I'll just open it and haha. This is a pencil point tip or conical tip for that T12 iron that I've got sitting over there, so I might change the tip over and use this one. It's actually a Heiko T12BL, that's the code for it, but it's a nice fine point tip, so that'll make soldering on circuit boards like that over there a lot easier than what I'm doing now. Tip is cold. I went out and left the soldering iron on. They look exactly the same to me. As long as they plug in, should be alright. Yep, perfect. Alright, I'll turn the soldering iron back on and let this tip warm up and settle in. Alright, let that warm up. It will go all over the place and beep like that until the tip is calibrated, I guess, for want of a better term. It'll eventually settle down. The first tip did exactly the same thing, and it's actually settled now down to 380 degrees, so it's automatically calibrated itself. So I'll see if it melts solder. Yep, perfect. Alright, back in business. Cool beans. That soldering iron tip is much nicer to solder with. Now, the 820 is just tacked in there for now. So I'll plug this back in and we'll have a look at our DC offset. That is much better. 6 millivolts, 7 millivolt, and starting to stabilize. So that is a much more acceptable DC offset. I am much happier with that. As the amplifier settles, it'll start coming back down again. Very, very good. So now I'll make it permanent and solder the resistor in where the 1K5 was. Now, the DC offset, I will admit, originally with the 1K5 in there is perfectly acceptable. It's not that bad. However, if it can be lowered and made by modification better, then why not do it? So I'll update the project on PCBWay and say that the 1K5 is better off being changed to an 820 ohm instead. However, your results may differ. If you use different transistors other than the BC558s that the circuit is using now, it may lower or increase your DC offset, so it's best not to modify the circuit too much. Anyway, I'll get this resistor in. We're currently sitting at 4.8 millivolt DC offset, which is perfectly acceptable. So let me get busy doing that, and we'll come back when I've got something much more interesting to share. Penis! Alright, now the resistor is in permanently. Let's check her out. Absolutely fine. We're at 14 millivolts now, but that should decrease when it settles down. See, it's starting to fall off a bit. I honestly don't think I'm going to get it any better than that. So I'll just hook it up to the oscilloscope for the last time, and we'll just verify that the thing's still working. I was about to say no it doesn't, but then it does help to actually connect the input. It looks reasonably fine to me. Yeah, it's still functioning, so alright. Suppose I should hook it up to a speaker and see how it sounds. Okay, I got everything set up, Focusrite, laptop, speaker, all that sort of stuff. Let's see if the amplifier makes rude noises when we power it up now. A tiny bit of a thump there, but nothing major. So let's play a track. Sounds alright.
For your thoughts. I hate Brenda, and a bad guy hit me in the shin and I peed all on my pants.
Okay, that's probably copyright, so I'm not going to play too much of that. What I might do is I might hook up a bass guitar to the Focusrite and see how that sounds through it. sounds pretty good actually, as far as I'm concerned. This is what this amplifier's noise. That's what this amplifier is going to be used for anyway. Ow, I just hit myself in the head. The heatsink's mildly warm. Flash transistors fine. Input stage transistors are fine. So yeah, that was a win. The DC offset's probably still a little bit high, but it's better than it was. So Jesus Christ. I'll make the changes to the project on PCBWay. But I'm going to end this video here, and if you enjoyed this video, please remember to rate, comment and subscribe. And you can always follow me on Facebook and become a Patreon supporter for as little as $1 a month. The links are in the description as usual, guys. Anyway, this is the Astro Thief saying, see ya, have a great day.